Okay, I think we need to start our next session. This is going to be the session 4 of this event, and we will have 3 presentations today. The first presentation is on the topic Hydrogeochemical and Isotopic Monitoring of the Kestanbol Geothermal Field, Northwestern Turkey, and its relationship with seismic activity. This research will be presented by Deniz, ŞANLIYÜKSEL, YÜCEL. Dr. YÜCEL, are you here?
Yes, I'm here. Hello, Professor Deniz.
Hello, the floor is yours. You have 20 minutes. Please follow the time, okay?
Thank you very much. Hello, my colleagues, but I couldn't open my camera. I'm trying to share the screen. Can you see my screen?
Not yet. Yes, now it's coming. If you switch to the full screen or full presentation mode, we will see it easier.
Okay.
Okay. Yeah.
Okay. Thank you. Hello, my colleagues. Hello, Professor Gündüz. My name is Deniz, ŞANLIYÜKSEL, YÜCEL. I'm associate professor. I'm working at Department of Mining Engineering at Çanakkale 18 Mart University. I will present you hydrochemical and isotopic monitoring of the Kestamble geothermal field and its relationship with seismic activity. One of the highest temperature geothermal fields within the Biga Peninsula is Kestanbol, located about 50 kilometers southwest of Çanakkale and in Alexandria Trias Ancient Port City. These geothermal springs were used for medical treatments and bathing since the Hellenistic period. Nowadays, geothermal springs are utilized for thermal tourism and heating the spa. In this photo, you can see the historical remains and Kestamble spa. In the study, we aim to determine hydrogeochemical and isotopic compositions of geothermal and cold waters in the Kestamble geothermal field, and we investigate the effect of seismic activity on variations in the hydrogeochemical features of Kestamble geothermal waters. We collected water samples at 5 points from 1 geothermal well, 2 geothermal springs, and 2 cold springs. A total of 30 water samples were collected in 6 different periods during the years 2018 and 2019. The temperature, electrical conductivity, salinity, and pH measurements were carried out in the field. We collected water samples and measured cations, and selected elements were analyzed using ISPOES, and measured anions were analyzed by IC. The oxygen 18 and the deuterium of water samples were determined using the optic method. The tritium measurements were determined using an ultra-low level diffuse scintillation spectrometer. This is the geology of the study area. You can see the basement of the basement rocks in Kestamble geothermal field is Lower Cambrian Gate formation, and the formation composed of mainly metal sandstone, phyllite, calcareous, and mica schist. The basement rocks overlain by middle-late Permian Rosalan formation. The formation consists of dark gray, pink, white-colored battery crystallite limestone, phyllite, and metasandstone. The upper Oligocene and lower Miocene age Kestamble Pluton represented by mainly intensely fractured and cracked karst, monzonite, monzonodioric porphyry, cyanide porphyry, and emplaced by cutting all older units. And the Pleoquaternary Byramic formation overlies older units, you can see here. And above this conformity and consists of slightly cemented red-brown color conglomerate sandstone and mudstone. The Quaternary alluvium uncontrollably overlies all older units and represents the youngest sedimentary sequence, consisting of slightly consolidated and unconsolidated gravel, sand, clay, and mud transported by the Ilıca stream. And also several geothermal springs and leakage are observed around the Kestamble geothermal field. You can see this UAV orthophoto. The alignment of these geothermal springs and this leakage are parallel to the Ilıca stream. A well was drilled in aquifer in 1975, a depth of 290 meters by the General Director of Mineral Research and Exploration to evaluate the geothermal potential of Kestanbol geothermal field. You can see this photo of the geothermal well. Based on the lithology and hydrochemical data of the well, this geothermal field is governed by two major aquifer systems. The primary reservoir rocks are partly fractured gneiss, and the secondary reservoir is the effectively fractured syenite. The geothermal water reached ground surface through the artesian flow. The reservoir temperature and flow rate of geothermal water was identified as 75 degrees Celsius and 25 liters per second, respectively. Nowadays, the flow rate of the well is 1 liter per second, and probably due to the scaling that occurs in the well over time. From the inverse solutions for the focal mechanisms of 5 earthquakes, you can see in the figure, larger than magnitude 3.5 occurring in the Kestanbol geothermal field, it's understood that Kaplıca fault is a right lateral strike slip fault with normal component. Additionally, strike is observed to be northeast to southwest and east-northeast to west-southwest. Also, earthquake data confirmed with the Kaplıca fault, which was morphologically determined to extend along the Ilıca stream in the field. From our study period from July 2018 to June 2019, 20 earthquakes with magnitude 3.5 and above occurred in the close surroundings of the Kestanbol geothermal field. You can see in this figure. The most significant of these earthquakes was February 20 Tarışkayvacık earthquake. And during our monitoring period, no earthquake occurred on the Kaplıca fault. The temperatures varied from 59 to 59.5 to 74.6 degrees Celsius in geothermal waters, and geothermal waters were slightly acidic, and in contrast, the cold waters were alkaline. The EC of geothermal waters very high, more than 30,000 microsiemens per centimeters, and salinity also is very high. And you can see the agency pH value 8.21 and very high electrical conductivity value 58,200 microsiemens per centimeter, and high salinity value. The geothermal waters are sodium chloride water type, and cold waters are calcium bicarbonate and chloride water types. You can see in the paper diagram, and the geothermal and cold waters are plotted different fields. Geothermal waters is close to seawater in the Piper diagram. Low mineralized cold waters represents the outflow of local groundwater recharging and circulating in the future of the intrusion of the Kestanbol Pluton. In the Scholar diagram, suggests that geothermal waters originate in the same geothermal aquifer. You can see here, these are the geothermal waters, cold waters, and these are the sea waters. The mean sodium chloride concentrations of geothermal waters was found to be 80,000 and milligram per liter, and the sodium chloride ratio, similar sodium chloride ratios, and slight differences in bore chloride and brom chloride ratios between seawater and the geothermal water suggest altered fossil seawater as the source of the saline end member. Because we use chlor and bromide because they are conservative elements and that are less affected by water-rock interactions. And in Kestamble geothermal field, there is the scaling problems, and these scaling minerals are the calcite, halite, and siderite. You can see in this image, these are the calcites and these are the halite, siderite crystals. And the arsenic, iron, and manganese concentrations of scale are higher than the mean values for the continental crust. Also, high concentrations of arsenic, barium, iron, lithium, and manganese in geothermal waters were mainly derived from prolonged water-rock interaction under high temperature conditions. Since the Kestanbol geothermal waters are not filtered or reinjected after being used in the spa, the discharge of geothermal wastewater has resulted in thermal and chemical contamination of soil and waterways. You can see this contamination in this photo. All of the geothermal waters fall in the area of partly accumulated or mixed waters in Gegenbach diagram. The sodium-potassium geothermometers give unreasonable temperatures of more than 200 degrees Celsius, and it's probably due to the altered seawater intrusion into the reservoir. The Chalcedony geothermometer with a mean value of 120 degrees Celsius was the most appropriate silica geothermometer to estimate reservoir temperature of the Kestanbol geothermal waters. The low mineralized cold waters, you can see this diagram, they are located between global meteoric waterline and Marmara meteoric waterline, indicating meteoric origin. The oxygen 18 and deuterium values of geothermal waters are more positive with respect to cold waters. And Mutzenberg stated that Tuzla is another geothermal field. It's 20 kilometers south of Kestanbol. And Kestanbol geothermal waters probably have the same origin, since a similar chemical composition is observed in both geothermal systems. They have similar chemical characteristics, but Tuzla geothermal water is less diluted and less cooled, according to Kestanbol geothermal waters. The geothermal waters fall in the line represents mixing and dilution between brines of Nisros Island. This island is 15 kilometers from Turkish coast, from Greece, and the local groundwater. The plotted oxygen 18 and deuterium values of meteoric waters, Kestanbol and Tuzla geothermal waters are positively correlated with Nisros Island geothermal well. And so the origin of the Kestanbol geothermal water is deep-seated hot fossil seawater that is diluted and cooled during the movement and flushing of infiltrating meteoric water. The treating contents of cold waters vary from 0.5 to 4.91 tritium unit, and this reflects the seasonal variations affecting the meteoric waters. The tritium values of geothermal waters were below 0.46 tritium unit, indicating the system was recharged before 50s. You can see the correlation between tritium and electrical conductivity. These are the cold waters, and they are affecting seasonal variations. These are the hot geothermal waters, and this is the Aegean Sea. We want to determine the effect of active tectonic regime on hydrochemical change in geothermal water. So we chose the Kestamble geothermal well K1 because it doesn't affect from the atmospheric conditions or meteorological conditions. During our study period, 20 earthquakes with magnitude 3.5 and above were recorded, and we determined some temporal variations in physical, chemical, and chemical compositions of geothermal waters. Especially after the Tartışık earthquake, the temperature and electrical conductivity of geothermal water were reduced and the pH value increased. As the chloride is considered to be a conservative constituent of geothermal waters, the decrease in the chloride concentration points to a geothermal cold water mixing process. It seems to be related to increased seismic activity, and also the decrease in temperature and electrical conductivity of geothermal water after Tartışık earthquake also supports this data. Then we come to the last slide. These are our conclusions. Three principal processes determine hydrogeochemical and isotopic characterization of Kestanbol geothermal waters. The first is the meteoric water fossil seawater mixing, the second prolonged water-rock interactions, and the third is the active tectonic. Meteoric water undergoes deep circulation and heated by the Kestanbol pluton and high geothermal gradient, and interacts with reservoir rocks at higher temperatures, mixing with deep-seated hot fossil seawater before rising along the permeable Kaplıca fault and fracture zones and emerging in the form of Kestanbol geothermal water. The maximum discharge temperature of geothermal well was measured 74.6 degrees Celsius. However, the reservoir temperature was about 120 degrees Celsius, calculated with Calcedony geothermometer. A detailed geophysical survey is required to develop the geothermal energy potential of the Kestamble field, and new drillings must be performed to increase the flow rate and temperature of water. And long-term, regular, more frequent monitoring of the hydrochemical characteristics of geothermal waters will lead to better understanding of their relationship to seismic activities in the Kestamble geothermal field. We are grateful to Professor Baba, Professor Chandrasekharan, Professor Tatar as editors for this special issue for this workshop. We would like to thank Scientific Research Project Coordination Unit of Çanakkale 18 Mart University, and we would also like to thank three reviewers. Thank you for your attention.
Okay, thank you, Dr. Yücel. Are there any questions for Dr. Yücel? One quick question, maybe.
I have a question, Professor Gündüz.
Yes, please, go ahead.
Deniz, thank you very much for your interesting work. I'm just wondering about the 2017 Ayvacık and Gülpınar earthquakes. Do you have any hydrogeochemical and some other data from the Kestanbol geothermal field before the occurrence of this 2017 Ayvacık and Gülpınar earthquake of 5.4? And did you have any chance to compare the data before and after the earthquake?
No, unfortunately, we didn't compare the data. I have no information about this, but I will check later. We can check the previous studies maybe.
Yeah,
And
this is important, yeah, because your sampling period was between 2018 and 19, so just after the earthquake, but it is worth to check the data before the earthquake as well. Thank you very much.
Thank you.